Now we look at the third position, where here object is at C, that means center of curvature. Then obviously image is formed at C only, and it is going to be same size, inverted and real. So remember, real is one which can be traced on the screen, that you can experience, whereas virtual cannot be taken on the screen. So here almost all cases you will get the real images for concave mirror, except for one case that we are going to look at, and magnification is going to be 1, because size of the object is same as that of size of the image, but negative, 1 and negative. So how the picture is going to be? The picture is going to be like this. So see here, if at all I look at the mirror here, now from the pole draw the principal axis. So this is the pole and this is the principal axis you have, and here it is the center of the curvature. This is the center of the curvature C, this is F and this is P. Now object is here itself, AB, this is the object. So here what happens, whenever I look at the ray which is falling parallel to this, will be coming back, parallel beam always comes back with the focus, through the focus point. Then when I look at the ray which is falling at the pole, will be reflected back with the same angle. Therefore this is going to meet at the same point over here. That means the image is going to be here. This is going to be the image. Now you can also think of C. C to C is the same line. Therefore you can think of the image. This is a reflected ray. The image is A dash B dash. Therefore AB is equal to A dash B dash. So image is formed at C only, object is at C, image is also at C, but inverted. That is the reason negative magnification, and size is going to be same. That is the reason 1 we are writing as the magnification, and it is inverted and real. You can trace it on the screen. So this is the case of when object is placed at the center of curvature. Similarly, we will think of the case where object is between C and F. So the fourth case we will look at, object is between C and F. Then image is formed beyond C, important. So it's very simple, as we are moving towards the surface, the image is moving away from the surface. That's the only thing you need to remember. And it is magnified. So it is magnified and real inverted, and magnification is going to be greater than 1 but negative only, because image is inverted. So how the ray diagram is going to be? See here, the ray diagram is going to be like this. So here you take the concave mirror and this is the pole. So this is the principal axis drawn from the pole, and now let us say this is C and this is F, and now the object is somewhere here. So let us say this is A and B. Here the parallel beam, as usual the parallel light will be going through the focus and is meeting at some other point. And now when I look at this is meeting at, see here, this is meeting at somewhere here. So they are meeting somewhere here. This is the meeting point. Now from the center of curvature, if I draw, this is the center of curvature. So this is also meeting somewhere here. Therefore the image is coming out to be this, that is A dash B dash. So here A dash B dash is greater than AB. So this is how the image formation takes place in case of object is between C and F. This is C, this is F, this is P. Between C and F, you are getting beyond this and is magnified. The size of this is going to be more than the size of this. So this is how you can write. And then you can think of the third, fourth, fifth case, that is when object is at focus. Object is at focus F. Then image will be formed at infinity. Just vice versa, ulta. Here when infinity, it is formed at focus. When object is at focus, image is formed at infinity. And it is magnified of course, real and inverted. So how it is going to be? So to look at this, I am just looking at the curved surface over here. Now this is the concave mirror I have. From this is the principal focus. So this is the principal focus I have. This is the principal focus. This is pole. This is the principal axis in fact. And here it is C. And this is the focus. So now object is placed at the focus. So here is the object. Let us say this is A and B. Now what happens? Whenever it is falling over here, then what happens? It is just going through the focus only here, and when it is falling over here, it is moving with the same angle, and here these two are not meeting. That means image is formed at infinity. So magnified and image is formed at infinity. So M is far greater than 1 and negative again. So this is how the image is formed in case of object is at focus. Now we can see the last case, that is if at all object is between focus and pole, then this is the different case. Image is beyond the mirror, other side of the mirror you will be getting, and it is magnified, it is virtual, that means you cannot trace it on the screen, and also virtual, magnified and erect. You call it as erect because it is vertical only, not inverted. So how it happens means, you can just think of the concave mirror I am writing over here. This is the concave mirror I have, and now this is the principal focus. So principal axis, this is the P, and now this is F, and this is C, let us suppose. Object is placed over here. Then what happens? Here, whenever it is coming over here, this will be reflected in this manner, and here whatever coming over here is reflected in this manner. So I am able to get this as magnified A dash B dash. So here this is going to be the, whenever it is formed between F and P, the diagram is going to be this. So here it is virtual, and beyond the mirror I am getting here. And it's a virtual image. So this is how you can get it. So here, instead of reflecting back over here, you can take the continuation of this. The image is formed over here, and similarly the image is formed over here, along the focus. So this is how it takes place. So this is how it takes place. So I will be getting the magnified image, erect. So these are the various images formation due to the various positions of the object.